Thanks for taking the time to watch this video. We're the original DIYsolar.com, and we'd like to share a few important insights from nearly 3 decades in the solar industry. For more than 27 years, we've designed solar power systems, supplied equipment, and performed component-level inverter repairs for tens of thousands of customers across the United States and Canada. Through our factory-authorized inverter repair center, we've supported projects ranging from small residential and RV systems to large commercial installations. And over those decades of real-world experience, one thing has become very clear. High-frequency, transformerless inverters are simply not well suited for serious off-grid or home battery backup applications. In this video, we'll explain why that is, and help you understand the key differences between inverter technologies, so you can make a confident, well-informed decision when choosing the right inverter for your next project. Here's a fact most YouTube influencers won't tell you, because it doesn't fit their script. High-frequency transformerless inverters didn't become popular because they're better. They became popular because they're cheaper to build. Remove the transformer and suddenly the manufacturer saves a fortune in copper, iron, shipping weight, and component cost. That's great for factory margins. But when the grid goes down and real loads hit the system, the homeowner is the one left holding the compromise. In this video, we're going to walk you through 10 critical reasons why high-frequency, transformerless inverters, regardless of brand name or price, simply have no place in any long-term, real-world off-grid or home battery backup system.
Fail number 10. All high-frequency transformerless inverters, regardless of brand or size, offer the poorest peak power capacities out of any other inverter technology on the market. A high surge capacity is critical for the long-term starting of high-inductance loads, such as power tools, microwave ovens, air conditioning, and motorized household appliances. Virtually any appliance that uses a transformer or electric motor. You may be able to start some of these high surge loads when your high-frequency inverter is new, but the long-term, repeated powering of these high-inductance loads will shorten the life expectancy of your high-frequency inverter. Fail number 9. The components used in high-frequency transformerless inverters operate under higher levels of stress than the components used in low-frequency transformer-based inverters, due to their higher operating voltages and higher switching speeds, which can lead to excessive wear on the inverter's MOSFETs, diodes, and capacitors, again shortening the life expectancy of the inverter. Fail number 8. In order to sell these high-frequency inverters as cheaply as they do, the Chinese had to remove the most important component in an inverter, the output transformer, and replaced it with a complex mashup of cheap Chinese-made diodes, MOSFETs, capacitors, and inductors. In other words, you'll get what you paid for. You may think that you're saving some money up front by purchasing one of these low-cost, high-frequency transformerless inverters, but after you've had to replace it for the second or third time over the next 2 to 5 years, you'll realize, like so many others before you, that you dumped your money down that proverbial drain. Fail number 7. Because of their exceedingly complex design, high parts count, and the lack of available schematics, once the warranty on a high-frequency inverter runs out, it will be nearly impossible and expensive to find a shop that will perform repairs. That's why they're known as throwaway inverters. Fail number 6. Due to the lack of an iron core, copper-wound transformer, high-frequency inverters tend to produce a distorted waveform when starting and powering heavy or high-inductance loads. This distorted sine wave can damage sensitive electronic loads that are connected to the inverter's output. That's why you'll rarely see any YouTube affiliate advertisers with an oscilloscope connected to the inverter that they're promoting. Fail number 5. If you were expecting or are in need of a quieter inverter, then you should avoid a high-frequency inverter. Because high-frequency inverters operate at a much higher switching speed, when under load, they require much more aggressive cooling measures, which translates into multiple, noisy, high-speed cooling fans. While low-frequency inverters do produce some fan noise, the sound is nowhere near the level of a high-frequency inverter. Fail number 4. Low-frequency transformer-based inverters are far more expensive to build than high-frequency transformerless inverters. But now, because of technological advancements and more competition entering the market, Despite the major differences in performance, safety, and reliability, the price difference between these two technologies has substantially narrowed to just a few dollars. From a financial perspective, it simply no longer makes sense to purchase a high-frequency transformerless inverter. Fail number 3. First of all, I'd like to say that there are a lot of great products out there that are manufactured in China. On the other hand, especially when it comes to high-frequency inverter products, unfortunately, rogue communication devices not listed in product documents have been found in some Chinese-made high-frequency solar power inverters by US experts. These rogue components provide additional undocumented communication channels that could allow firewalls to be circumvented remotely, with potentially catastrophic consequences. Fail number 2. Over the past 27 years in this industry, we've watched many high-frequency inverter manufacturers make only superficial changes to their equipment, altering the exterior appearance while retaining the same fundamentally unreliable internal architecture. Today, these inadequately engineered inverters are simply packaged in larger metal enclosures with added MPPT charging circuitry and a few low-cost circuit breakers. But the core design remains essentially the same as it was 3 decades ago. And finally, fail number 1. The most important and dangerous issue with high-frequency transformerless inverters is their lack of an iron core, copper-wound output transformer. Without this transformer to provide galvanic isolation between the inverter's DC boost stage and its AC output, during a catastrophic failure of the inverter's control circuitry, or its H-bridge circuit, high amperage DC current can pass through the AC circuit breaker that can not only damage your AC appliances, but can also set those appliances or your EV on fire.
If after watching this video you're still not convinced to avoid high-frequency transformerless inverters for your off-grid or home backup system, we have one final recommendation. When evaluating product recommendations on YouTube, exercise caution with videos centered around unboxings, quick reviews, teardowns, or basic installation walkthroughs. While these videos may be entertaining or helpful for seeing a product out of the box, they rarely provide meaningful insight into long-term reliability, engineering quality, or real-world performance. Instead, we strongly recommend conducting thorough due diligence on any brand or model of solar system component you are considering. One simple and highly effective step is to search for documented consumer complaints. For example, enter the product's model name followed by the word complaints into Google's search bar. This quick search can reveal a consolidated view of real-world user experiences, as Google aggregates feedback and reports from a wide range of credible sources across the internet. Reviewing this information can provide valuable insight into product reliability, recurring performance issues, and long-term customer satisfaction, helping you make a far more informed purchasing decision before investing in your system. While you're already on Google, here's a simple way to cut through the marketing noise and verify whether the 10 reasons we've outlined for avoiding high-frequency transformerless inverters actually hold up in the real world. Don't just take our word for it. Ask Google directly. For example, try typing in, "Can a high-frequency transformerless inverter damage your appliances?" What you'll find is that Google pulls information from a wide range of technical sources, forums, manufacturer notes, and real user experiences. The answers consistently point to known concerns, such as reduced surge capacity, less stable voltage under load, higher sensitivity to inductive loads, and in some cases, increased risk of stress or premature wear on appliances like refrigerators, air conditioners, and power tools. The reason we tell you to ask Google about the real-world problems with high-frequency inverters, instead of relying on a YouTube influencer, is simple. Google doesn't have a commission link. It aggregates information from thousands of independent sources, technical discussions, documented failures, user experiences, and manufacturer data, giving you a far more objective picture of how these products actually perform over time. Most YouTube influencers? That's a different story. They're not inverter engineers. They're not manufacturers. They're not repair technicians with years of hands-on failure analysis. And despite the friendly tone on camera, they're not there to protect your investment. They're marketers. Their revenue depends on clicks, affiliate links, and product promotion, often for the very high-frequency transformerless inverters that generate the most sales, not the best long-term results. So when you see glowing reviews, ask yourself, is this real engineering insight or a well-produced sales pitch? Because when your entire home's power depends on that inverter, you don't want opinions driven by commissions. You want answers backed by real-world performance.